Now in this lecture we'll find out the area of the orange shape using two different methods. In the drawing we have square ABCD. One side of square ABCD equals to 10 units, and inside square ABCD we have two semicircles that intersect with each other and they create the blue shape. The common area of the two semicircles, semicircle CPD and semicircle DPA, the common area of those two semicircles is the blue lens. And we also have here a quarter circle ABQD that intersects with this semicircle, and in this way they create the common area that is the big lens, this big lens. And our mission is to find out the area of shape QPD, that is the orange shape. Our mission is to find out the area of this orange shape. Okay, so we'll start with the first method, but before that I will explain to you what is the area of a sector. The green shape is a sector that is a part of a circle, and the area of this sector, the area of the green sector, it will be equal to the area of this circle, that is pi r square, times the ratio between angle theta over 2 pi. 2 pi in radians, so it is actually 360 degrees in terms of degrees. So this formula is a formula that in the units of radians. So the area of this green sector equals to pi r squared, that is the area of these circles, times the ratio between the angle theta and 2 pi. 2 pi is 360 degrees. In terms of degrees, it is 360 degrees. So 2 pi radians is 360 degrees. So we divide the size of this angle by 360 degrees actually, that is 2 pi, and then we multiply it by the area of this circle, that is pi r square. In this way we get the area of this green sector. Okay, so the area of this green sector equals to theta over 2 pi times pi r square. So this is the first thing that I want to explain. And the second thing is the area of this circular segment, the green circular segment AB. The area of this circular segment AB, it is equal to the area of sector BOA, the area of sector BOA minus the area of triangle BOA. If you subtract the area of triangle BOA from the area of sector BOA, we get exactly the area of the green circular segment AB. So the area of the green circular segment AB equals to the area of sector AOB minus the area of triangle AOB. Okay? So here we will actually, in the next step, we'll find out the area of a length. What is a length? When two circles or semicircles intersect with each other, they create a common area, and the common area that they create is defined as the length. So this is the common area that those two circles, that those two semicircles that intersect with each other creates, and this common area is defined as the length. So we find out the area of this length, and then we'll use the formula that we will find in order to find out the area of this green orange shape DPQ, and the area of the orange shape will be equal to the area of the big lens. This is the area of the big lens minus the area of the blue lens. The area of the big lens minus the area of the blue lens will be equal to the area, the orange area. The orange area, the area of shape DPQ, that is the area of the orange shape. Okay, so we'll use the general formula that we will find for the area of a lens in order to find out the area of this big lens minus the area of the blue lens will give us the area of the orange shape DPQ. Okay, so we start with the first step to find out the area of this shape that was created by the intersection of those two semicircles. Okay, so first of all we will define the center of this semicircle as point O, and we define the vertex here as point L. So point O is the center of this semicircle, point L is a point on the semicircle itself. This is exactly the definition of a radius. So line segment OL is the radius of this semicircle. We'll define the radius of this semicircle as A. So here we have this radius OL. It is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of this tangent ML, is the point of tendency of tangent ML with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius LO. So if ML is perpendicular to LO, it means that this angle equals to 90 degrees. It is a right angle. Okay, according to the rule that the tangent to a circle is perpendicular to the radius drawn to its point of tendency. Okay, and we define the radius of this semicircle as B. And from the center of this semicircle, we will draw the radius of this semicircle in such a way that it will be tangent to this semicircle. This is point N. So the radius MN, first of all, it is the radius of this semicircle. Why? Because it starts from the center of the semicircle and ends at point N. That is the point on the semicircle itself. That is to say, MN is the radius of this semicircle that is equal to B units. And the radius mn is tangent to this semicircle at point n. Point n is the point of tendency. Point of tangency of tangent mn in this semicircle. Here we draw the radius of this semicircle in such a way that it will be drawn to the point of tendency, that is to say, it is drawn to point n, that is the point of tendency of tangent mn with this semicircle. So this is the radius of ON, is the radius of this semicircle, because it starts from the center of the semicircle, that is to say from point O, and ends at point N, that is the point of the semicircle itself. That is to say ON is the radius of this semicircle, and the radius of this semicircle equals to A according to our definition. So here we have the radius ON that is drawn to the point of tendency, that is to say it is drawn to point N, that is the point of tendency of tangent MN with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent MN, this tangent will be perpendicular to the radius ON. So if MN is perpendicular to NO, it means that this angle equals to 90 degrees. Okay? In the next step, we'll join points O and M together by a straight line. We'll join points L and N by a straight line. Right. This is the straight line that joins points N and N together. So here we divided this length into two circular segments. So we'll find out the area of this green circular segment, and then we'll find out the area of the other circular segment, the lower circular segment, and in this way we'll find this will be the area of this length, and then we'll use the area, the general formula for the area of any length to find out the area of the big lens, and to find out the area of the blue lens, and then we'll subtract from the area of the big lens the area of the blue lens, and this will give us the area of the orange shape. Okay, so first we find out the area of circular segment LN, the green area. So what is the area of circular segment LN? So the area of the green shape of circular segment LN will be equal to the area of sector LON this is sector LON minus the area of triangle LON. Okay, minus the area of triangle LON. I repeat again, the area of the green circular segment LN the area of the green circular segment LN equals to the area of sector LON minus the area of triangle LON. This will give us the area of circular segment LN, the green area. So the area of sector LON first of all we have to find out the angle between the legs of this sector. So we define angle LON as theta, and those two triangles can go into each other. Triangle LON, this triangle can go into this triangle MON. Why? Because those two sides are equal to each other, they are both equal to 8, therefore they are equal to each other. Those two sides are also equal to each other, they are both equal to B, therefore they are equal to each other. And we have common side OM. Therefore, those two triangles can go into each other according to side rule. And for the fact that those two triangles can go into each other, we conclude that those two angles equal to each other. And if this angle equals to theta, it means that this angle must be also equal to theta because those two angles are equal to each other. So this angle must be also equal to theta because of the fact that those two triangles can go into each other. Okay, so in conclusion, angle LON equals to theta plus theta, that is 2 theta. So we found out that this angle LON equals to 2 theta, and the area of a sector equals to the angle between his legs is 2 theta over 2 pi, that is, in terms of degrees is 360 degrees. 2 pi radiani equals to 360 degrees times the area of the circle, that is pi r squared, but r equals to a, so it is pi a squared. Pi a squared. Okay, so this is the area of sector LON. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. And after we cancel pi, we have 2 in the numerator, 2 in the denominator, so 2 also will get cancelled. So what is left after we cancelled 2 and pi? What is left from this expression is pi theta a squared. That is to say, the area of sector LON is theta times A squared. In the next step, we'll find out the area. So the area of sector LON equals to theta times A squared. The next step, we'll find out the area of triangle LON. The angle between side LO, side ON is 2 theta. Therefore, the area of this triangle equals to the multiplication of the two sides by each other. That is to say, A times A is A squared times sinus the angle between those two sides, that is 2 theta, over 2. Okay? So, in conclusion, we found out that the area of the upper circular segment LN of the length equals to this expression, theta A squared minus A squared times sinus theta over 2. And here, in the next step, we'll find out the area of the lower circular segment LN. Actually, in the first method, here, in the first method, we don't have to calculate the area of the triangle at all. So this calculation is unnecessary. We don't have to calculate the area of a triangle at all, because we will add the two triangles together, and by adding the two triangles together, we will create two right triangles. The area of each triangle will be equal to A times B over 2. A times B over 2 plus A times B over 2 will be equal to A times B, and we will arrive to the conclusion that the area of the two triangles equals to A times B. In this way, we don't have to calculate the area of the triangle at all, because the area of the two triangles is A times B, and A times B is the multiplication of the two radii of the two circles or semicircles by each other. So this step is unnecessary. We don't have to calculate the area of this triangle at all. So in the next step, we will find out the area of the orange circular segment. Okay, so the area of the orange circular segment actually, the idea of the first method is that you don't have to calculate the area of the triangles at all. And when you don't have to calculate the area of the two triangles at all, it saves you a lot of time. But in the second method, we will calculate the area of the triangles, that it will take us more time. Okay, so here the area of the lower circular segment, the orange circular segment equals to the area of sector LON, the area of sector LON it is not, it is the area of sector LMN, the area of this sector, the area of sector LMN. This is sector LMN minus the area of triangle LMN. Minus the area of triangle LMN. So here we have to calculate the angle between the legs of sector LON, the angle between side LN and side NN. So we'll focus on the right angle OLN. This angle equals to theta. This angle equals to 90 degrees. So this angle must be equal to 90 degrees minus theta. In terms of radians, is 90 degrees is pi over 2 radians minus theta. Okay. So in this, the other right angle, this angle equals to theta, this angle equals to 90 degrees. This angle must be also equal to pi over 2 minus theta in order to complete the sum of the angles in the triangle to 180 degrees. This angle must be equal to theta over 2 minus pi over 2 minus theta. So the sum of those two angles will be equal to the size of angle LMN. So the size of this angle LMN, will be equal to pi over 2 minus theta plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi. Minus theta plus minus theta is minus 2 theta. So in conclusion, we found out that the size of angle LMN, that is the angle between the legs of sector LMN, it is equals to theta minus pi minus 2 theta. Pi minus 2 theta. So here, the angle between the legs of sector LMN equals to pi minus 2 theta. Okay? So we know that the area of the sector equals to the angle between the legs, that is pi minus 2 theta, over 2 pi, that is 360 degrees, in terms of 2 pi is 360 degrees in terms of angles, in terms of degrees. So it is pi minus 2 theta over 2 pi times the area of the circle, that is pi r squared. R equals to b, so it is pi b squared. You have pi in the numerator and pi in the denominator, so pi will get cancelled. We'll open the brackets here. We'll get that pi over 2 times b squared, pi b squared over 2 minus 2 theta over 2 b squared. We have 2 in the numerator, 2 in the numerator, so 2 will get cancelled. So the area of sector LMN, in conclusion, it is equals to pi b squared over 2 minus theta times b squared. Okay? So we actually found out the area of the two sectors, and from the area of the two sectors we have to subtract the area of the two triangles, and in this way we'll get the area of this length. That could be any length, okay? So what is the area of the two triangles? So first of all, we'll combine the two triangles together. Here we have triangle LON. The first triangle is triangle LON. Side LO equals to A, side ON equals to A, and the first triangle is triangle LMN. Triangle LMN. We know that MN, the length of MN is B, the length of LM is also B, and we also know that those two angles are right angles. So this angle equals to 90 degrees, it is a right angle, and this angle equals to 90 degrees. This angle equals to 90 degrees. So those two angles, they are both equal to 90 degrees. In the next step, we'll join points O and M together by a straight line. By joining points O and M in a straight line, we created here two right triangles. Okay, the right triangle LOM and the right triangle MON. Both those two triangles are right angles, and the area of the green right triangle, triangle LOM, equals to the base of the triangle that is B times the height to the base that is A over 2. The height creates 90 degrees with the base here. The area of the other triangle, triangle OMN, that is also a right triangle, equals to the base of the triangle that is A times the height to the base that is B over 2. So the areas, the sum of the areas of the two triangles will be equal to AB over 2 plus AB B over 2. AB over 2 plus AB over 2 is 2 times AB over 2. 2 over 2 is 1. So the area of the two triangles is AB. That is the reason that we don't have to calculate the area of the triangles at all, because the area of the two triangles will be equal to the multiplication of the two radii of the two shapes by each other. Okay? So, in conclusion, we will get that the area of this lens, the area of this lens that could be any lens equals to the sum of the areas of the two sectors, that is theta a square plus the other sector is pi b square over 2 minus theta b square, the sum of the two sectors, minus the area of the two triangles, and the area of the two triangles is AB, so it is minus AB. So in conclusion, we found the area of a lens that could be any lens that is equal to theta a square plus pi b square over 2 minus theta b square minus AB. Here we take theta as a common factor. So what is left of this expression after we took theta as a common factor? What is left is a square. And what is left from this expression after we took theta as a common factor? What is left is b square. Or what is left from this expression after we took theta as a common factor? What is left is actually minus b square. And we also have to add pi b square over 2 minus AB. Okay? That is the area of a lens. We can use this general formula for the area of a lens in order to find out the area of the big lens and the area of the blue lens. But first of all, we have to find out the value of theta. So here, I write down, we draw triangle LOM here in this page. We have triangle LOM. Actually, we'll get a formula that the only missing variables in this formula for the lens will be the radii of the two circles or semicircles or quarter circles, whatever two circular, whatever it will be, the two shapes that we want to find the area of the lens that is actually created by, it is the common area that was created by the intersection of the two circles or semicircles together. So we want a formula that the only missing variable in that formula will be only the radii of the two circles or semicircles or quarter circles, whatever. So this is triangle LOM. LO equals to A, LB equals to B. This is angle theta. In this formula, in this right triangle LOM, tangents theta equals to LM over LO. LM equals to B, LO equals to A. So in conclusion, we found out that tangents theta equals to B over A. So we know that tangent theta equals to B over A. Now, in order to find out the value of theta itself, you can see that in our formula we have theta. So we can do nothing with tangent theta because the variable in the formula for the area of a lens is theta. So we have to find out the value of theta itself. Tangent theta doesn't help us at all. So in order to find out the value of theta itself, we will operate the opposite function of tangents on the result, that is B over A, and in this case, in this way, we'll get the value of theta itself. So the opposite function of tangents is tangents minus 1. We will operate this opposite function on the result, that is B over A, and in this way we'll get the value of theta itself. And this is exactly what is missing for us. We want to find out the value of theta. In this way we can substitute the value of theta that we don't know what is the value of theta by tangents minus 1 of B over A. Okay? So here we'll substitute theta in the formula for the area of a lens by tangents minus 1, that is the opposite function of tangents, of B over A. And we will get that the area of any lens that is the common area that is created by the intersections of two circles or semicircles with each other. It is equal to A square times B square, A square minus B square times theta, and we already found out that theta equals to tangents minus 1 over B over tangents minus 1 of B over A plus pi B square over 2 minus AB. Okay? So actually this is the general formula for the area of any lens that we can use in order to find out the area of the big lens and the area of the blue lens. Okay, so we'll use this formula in order to find out the area of the big lens. So what is the area of the big lens? The area of the big lens, this is the big lens, yes? The big lens was created by the intersection of the quarter circle with this semicircle. So we want the radius of the quarter circle that is equal to 10 units, so A equals to 10, that is the radius of the quarter circle, and we also need the radius of the semicircle, because of the fact that the diameter of each semicircle, here this is the diameter of each semicircle, equals to 10 units, and the radius is half of it. So the diameter of each semicircle is 10 over 2. Okay, so the diameter of this semicircle is 10 over 2, that is 5. So B equals to 5 units, that is the radius of this semicircle. So now we found out the value of A and B, so we'll put these values inside this formula and we'll find out the area of the big lens. This will be the area of the big lens. So it is equal to A squared. A is 10, so A squared is 10 squared minus B squared. B is 5, so B squared is 5 squared times tangents minus 1. B is 5, A is 10, so 5 over 10 is 0.5 plus pi. B is 5, B squared is 5 squared, that is 25 over 2 minus A is 10 and B is 5, so it is 10 times 5. Okay, so actually we found out that the area of the big lens equals to 10 squared is 100, minus 5 squared is 25, 100 minus 25 is 75, so it is 75 times tangents minus 1 of 0.5 plus 25 over 2 is 12.5, so this expression in total equals to 12.5 pi. Minus 10 times 5 is minus 50. So in conclusion, we found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5, that is the opposite function of tangents, plus 12.5 pi minus 50. This is the area of the big lens. In the next step, we will find out the area of the blue lens, and then we will subtract from the area of the big lens the area of the blue lens, and in this way we get the area of the orange shape, dpq. So what is the area of the blue lens? The area of the blue lens this blue lens were created by the intersection of the two semicircles with each other. The blue lens is the common area of the two semicircles. So we want to find out the radius of any semicircle, and we have already found out that if the diameter of the semicircle equals to 10 units, it means that the radius equals to 5 units. So the radii of the two semicircles, they are equal to 5 units, each one equals to 5 units. So A equals to 5 units, and B also equals to 5 units. Okay, so the only thing that is left to do is to put the value of A and B inside this formula, and we find out the area of the blue lens. So here the area of the blue lens equals to, according to this formula, that is true for any lens, A squared minus B squared. A is 5, B is 5, so it is 5 squared minus 5 squared, that is 0, times tangents minus 1. B over A is 5 over 5, that is 1. Anyway, this expression will be equal to 0, so we don't care about it at all. So this expression will be equal to 0. Plus pi over 2 times B squared. B is 5, so B squared is 5 squared, that is 25. Minus A times B. A is 5, B is 5. So A times B is 5 times 5, that is minus 25, because we have minus here. So the area of the blue lens equals to, this expression equals to 0, plus 25 over 2 is 12.5. So this expression in total equals to 12.5 pi minus 25. So we found out that the area of the blue lens equals to 12.5 pi minus 25. This is the area of the blue lens. And as I've already mentioned, the area of the orange shape DPQ equals to the area of the big lens. This is the area of the big lens minus the area of the blue shape will give us the area of the orange shape DPQ. Okay, so write it down. The area of the orange shape DPQ, the area of the orange shape DPQ equals to the area of the big lens, the area of the big lens. This is the area of the big lens minus the area of the blue lens. Okay, so the area of the orange shape equals to the area of the big lens, and we have already found out that the area of the big lens equals to 2075 times tangents minus 1 of 0.5 plus 12.5 pi minus 50, and from the area of the big lens we have to subtract the area of the blue lens, and this way we get the area of the orange shape. And we already found out that the area of the blue lens equals to 12.5 pi minus 25. So here we'll open the brackets here, and we'll get that the area of the orange shape DPQ, this orange shape DPQ, equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. Here we open the brackets here and we get minus 12.5 pi, and here we have minus 25 is plus 25. Okay, so here we have 12.5 pi minus 12.5 pi is 0, and 25 minus 50 is minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5, and here, as I already said, 25 minus 50 is minus 25. Okay. So we actually found out that the area of the blue shape equals to 75 times tangents minus 1 of 0.5 minus 25. The value of tangents minus 1, that is the opposite tangents, the opposite function of tangents of 0.5, it is equal to about 0.46, and we have to multiply it by 75, and we multiply it by 75, we'll get that is equal to 34.77 minus 25, and 34 minus 77 minus 25 is equal to 9.77 square units. Okay, we actually finished with the first method. We found out that the area of this green shape DPQ here is equal to 9.77 square units. So in the next step I will present to you the second method. So in the second method, we will not find general formula for the area of any length, but we will find out directly of the area of the big length, and we will subtract the area of the big length from the area, we will subtract the area of the blue length from the area of the big length. In this way we get the area of the orange shape DPQ. Okay, so we will actually relate to this specific drawing. We have already found out that the radii of each semicircle equals to 10 units, and the radius of the quarter circle equals to 10 units, and the radius of the small circle equals to, of the semicircles, they are equal to 5 units. So we'll find out the area of the blue lens, we find out the area of the big lens, and we'll subtract the area of the blue lens from the area of the big lens. In this way, we'll find out the area of the orange shape DPQ. Okay, so this is actually our two semicircles that intersect with each other, and we know here that we have already found out that this angle equals to 90 degrees. This angle also equals to 90 degrees according to the first method. We'll join the 2 points together here with a straight line. This is O, M, L, N. This angle equals to theta, this angle equals to theta. The radius of this semicircle equals to 5 units. The radius of this semicircle also equals to 5 units. They have the same radius. So it is 5. This is the radius of this semicircle that is equal to 5 units. And here we will join points L and N together by a straight line. Because of the fact that the two semicircles have the same radius, it means that they are identical, and therefore the lengths that they created by the intersection of one with each other, when we draw the straight line LN, it created, this is LN, this shape is the mirror image of this shape. So we can find out the area of this circular segment. We'll multiply it by 2, and in this way we'll find out the area of the blue shape. Why we'll find out the area of the blue shape? Because of the fact that the blue shape was created by the intersection of the two semicircles with each other. It is the common area that created by the intersections of those two semicircles by each other. Actually, they intersect with each other in 90 degrees. So this is the common area, this is the blue shape. So in this way, we find out the area of the blue shape. Okay, so what is the area of this circular segment LN, the green circular segment LN? So actually, here the area of the green circular segment Ln equals to the area of sector LON. The area of sector LON this is sector LON. It is very easy to see that sector LON is a quarter circle, of course. Minus the area of triangle LON. Triangle LON minus the area of triangle LON. So this is triangle LON. This angle equals to 90 degrees. This angle equals to 90 degrees, and that is the reason that LON is a quarter circle. Actually, sector LON is a quarter circle. And so here LO equals to 5 units, ON equals to 5 units also. LO equals to 5 and ON equals to 5. So the area of a quarter circle equals to the area of the circle, that is pi r square, and r equals to 5, so it is pi times 5 square over 4. This is the area of any quarter circle. The area of any quarter circle equals to the area of the circle over 4. Minus the area of the right triangle LON. The area of the right triangle LON is 5 times 5 over 2. The height, the base, that is 5 times the height of the base, that is 5 over 2. Okay? And then we will have to multiply the area of this circular segment Ln by 2. In this way we'll get the area of the blue lens, because the upper circular segment is identical to the lower circular segment, and the upper circular segment plus the lower circular segment equals exactly to the area of the blue shape. Okay, so here we have 5 square is 25, so it is 25 pi over 4 minus 5 times 5 is 25 over 2. So here we will multiply this area by 2, and in this way we will get the area of the blue shape. So the area of the blue shape, this blue shape, blue lens. It is blue lens, not blue shape, but the area of the blue lens will be equal to 2 times the area of circular segment Ln. 2 times the area of this circular segment Ln. So here we'll divide both the numerator and the denominator by 2. So here 2 over 2 is 1, so it is here 25 pi over, we divide both the numerator and the denominator by 2, so 4 over 2 is 2. So this expression after multiplied by 2 equals to 25 pi over 2 minus 2 times 25 over 2 equals to 25. So in conclusion, we found out that the area of the blue lens, equals to 25 over 2 is 12.5 pi minus 25. So this is the area of the blue lens. Okay, this is the area of the blue lens. So we finished with the first step. We found out the area of the blue lens. The area of the blue lens equals to 12.5 pi minus 25 square units. In the next step, we'll find out the area of the big lens that consists of the blue lens, and also the orange shape. Okay. As I've already said, this blue lens was created by intersection of the quarter circle with this semicircle. The common area was created by the intersection of the quarter circle with the semicircle. Okay, so this is the big area. We know that the radius of the quarter circle equals to 10 units. So here we join the center of this semicircle with the center of the quarter circle. We know that the area, the radius of the semicircle equals to 5 units, so here we draw tangent this radius PO is a tangent to this quarter circle, and we have the radius of the quarter circle. This is the radius of the quarter circle that is drawn to the point of tendency, that is to say it is drawn to point O. that is the point of tendency of tangent PO with this quarter circle. And whenever you have the radius that is drawn to the point of tendency, then tangent PO will be perpendicular to the radius AO or OA. That is to say, if PO is perpendicular to OA, it means that this angle equals to 90 degrees. And here we also know that the quarter circle intersects with the semicircle in the angle that is equal to 90 degrees. So here the angle between the quarter circle and the semicircle equals to 90 degrees, or we can also see it as that we have the radius AD that is drawn to the point of tendency. That is to say, it is drawn to point D, that is the point of tendency of tangent PD with this quarter circle, and whenever you have a radius that is drawn to the point of tendency, then tangent PD will be perpendicular to the radius DA. So if PD is perpendicular to DA, it means that this angle equals to 90 degrees. Point P is the center of the semicircle. Point O is a point on the semicircle itself. This is exactly the definition of a radius. That is to say, PO is the radius of the semicircle that is equal to 5 units. Okay? It is very easy to see that those two triangles can go into each other, or triangle DAP can go into triangle POA according to side rule. Those two sides, they are both equal to 10 units, therefore they are equal to each other. Those two sides, they are both equal to 5 units, therefore they are equal to each other. And AP is the current side that belongs to both triangles. Therefore those two triangles can go into each other according to side rule. And from the fact that they can go to each other, we conclude that those two angles are equal to each other. So if this angle equals to theta, then this angle must be also equal to theta. Likewise, this angle equals to theta, this equals to 90 degrees, that is pi over 2, therefore the missing angle must be equal to pi over 2 minus theta. In order to complete the sum of the angles in this triangle 280 degrees, this angle must be equal to pi over 2 minus theta. Those two triangles can go into each other, so this angle must be also equal to pi over 2 minus theta. Okay? So here we will join points D and O together by a straight line. In this way, by joining points D and O in a straight line, we divided the big length into two parts. We'll find out the area of each part. We'll add the two areas together, and this way we'll find out the area of the big length. Very simple. Okay, here we'll find out the area of the upper circular segment DO. What is the area of the upper circular segment DO? The area of the upper circular segment DO. So I'll write it down here. We have here the upper circular segment DO in the green color. This is the upper circular segment DO. what is the area of the upper circular segment DO? The area of the upper circular segment DO equals to the area of sector DAO this is sector DAO minus the area of triangle DAO. Minus the area of triangle DAO. This is triangle DAO. You know that the angle between the legs of sector DAO equals to theta plus theta, that is 2 theta. That is also the angle between side DA and side AO in triangle DAO. It is 2 theta. So here, the area of sector DAO will be equal to 2 theta over 2 pi. We know that AO equals to 10 units, DA equals to 10 units, times pi r squared. The radius of the quarter circle is 10 units, so pi r squared is pi 10 squared, because r equals to 10. Okay? So the area, in conclusion, the area of sector DAO equals to 2 theta over 2 pi times pi r squared, r equals to 10, so it is pi times 10 squared. Okay, so here we have theta in the numerator and theta in the denominator, so theta, pi, we have pi in the numerator and pi in the denominator, so pi will get cancelled, and we left only with, and we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled also. So the area of sector DAO, in conclusion, is equals to 10 square is 100 times theta. This is the area of sector DAO. The next step we'll find out the area of triangle DAO. It is equal to the multiplication of the two sides together, that is 10 times 10 times sinus the angle between the two sides, is 2 theta over 2. Okay, so in conclusion, the area of circular segment, the upper circular segment DO equals to 100 times theta minus 10 times 10 is 100, and 100 over 2 is 50. So it is equals to 100 times theta minus 50 times sinus 2 theta. Okay, this is the area of circular segment DO. It is actually the upper side of the big length. They are of the upper side of the big length. But we actually know that the sinus 2 theta, we have the trigonometric identity that sinus 2 theta equals to 2 times sinus theta times cosine theta. We have this trigonometric identity. Here we have the right triangle DAO. This is the right triangle DAO, angle DAP. This angle equals to 90 degrees. This angle equals to theta. DP equals to 5 units. DO equals to 10 units. What is the value of the hypotenuse? We will implement the Pythagoras theorem on the right triangle DAP. In the right triangle DAP, according to the Pythagoras theorem, we get that PA squared, that is 10 squared, plus DP squared, that is 5 squared, equals to the square of the hypotenuse, that is AP squared. That is to say, AP squared equals to 10 squared is 100, plus 5 squared, that is 25. 100 plus 25 is 125. We'll take a root out of this equation and we get that AP, the hypotenuse, equals to the square root of 125. 125 equals to 25 times 5. We take a root out of this equation and we get that AP equals to the square root of 25 is 5. Inside the root we left only with 5. So in conclusion, the hypotenuse AP equals to 5 times square root of 5. So now, what is the value of sinus 2 theta? So the value of sinus 2 theta, according to this trigonometric identity, is equal to 2 times sinus theta. And according to this drawing, the value of sinus theta equals to dP over AP. dP is 5 and AP is 5 times square root of 5. So in conclusion, sinus theta equals to 5 over 5 times square root of 5. And what is the value of cosine theta? From this drawing, it is very easy to see that cosine theta equals to AP, AD over AP. AD is 10 and AP is 5 times square root of 5. So in conclusion, cosine theta equals to 10 over 5 times square root of 5. Okay? So here we have 5 in the numerator, 5 in the denominator, so 5 will get cancelled. So the numerator we have 2 times 10. In the numerator we have 2 times 10. In the denominator we have square root of 5 times square root of 5 is 5, so it is 5 times 5. So here 10 over 5 is 2, so we get that it is equal to 2 times 10 over 5 is 2, so in the denominator we left only with 5. 2 times 2 is 4 over 5. So in conclusion, we found out that sinus 2 theta equals to 4/5. Sinus 2 theta equals to 4/5. And what is the value of tangent theta? Tangent theta, if we focus on the right triangle ADP, tangent theta equals to dP over AD, that is to say, it is equal to 5 over 10. 5 over 10 is 0.5. So we found out that tangent theta equals to 0.5. Here we will operate the opposite function on the result 0.5 in order to find out the value of theta itself. So we get that tangents minus 1, that is the opposite function of tangents, when we operate it on 0.5, it is equal to theta itself. Okay. So actually we found out that in conclusion, found out that sinus 2 theta equals to 4/5, and tangents and theta itself equals to tangents minus 1 of 0.5. That is the opposite function of tangents. And according to what we already found out, the area of the upper segment of the big lens, the upper circular segment of the big lens, it is equal to 100 times theta minus 50 times sinus 2 theta. In the next step, we'll substitute theta by tangents minus 1 of 0.5, and we'll substitute sinus 2 theta by 4/5. We'll do it now, and we'll get that this is equal to the area of the circular segment, the upper circular segment of the big lens, equals to 100 times theta is tangents minus 1 of 0.5 minus 50 times sinus 2 theta. And we already found out that sinus 2 theta equals to 4/5. So we'll substitute sinus 2 theta by 4/5. And we'll get that the area of the upper circular segment of the big lens, in conclusion, it is equal to 100 times tangents minus 1 of 0.5. Here 50 over 5 is 10, and 10 times 4 is 40. So here, in conclusion, we found out that the area of the upper circular segment of the big lens equals to 100 times tangents minus 1 of 0.5 minus 40. In the next step, we will find out the area of the lower circular segment, and then we will add the two circular segments to each other, and this way we'll find out the area of the big lens. Okay, so in the next step we'll find out the area of the lower circular segment. That is to say, the area of this green shape, the lower circular segment. Okay, here we already found out that this angle equals 90 degrees. It is a right angle. Here we have A, D, this is 10, the radius of the quarter circle, and we join together the two centers by a straight line. This point is point P. So this is the radius of the semicircle that is equal to 5 units. dp also the radius of the semicircle that is equal to 5 units. We have already found out that here we join those two points together by a straight line. Angle DPO, this angle equals to pi over 2 minus theta minus plus pi over 2 minus theta. Pi over 2 plus pi over 2 is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, this angle DPO equals to pi minus 2 theta. So actually, the area of the lower circular segment, the green shape, the lower circular segment, the area of this green shape, the lower circular segment, equals to the area of sector DPO, the area of sector DPO, this is the area of sector DPO, the angle DPO equals to pi minus 2 theta minus the area of triangle DPO. This is triangle DPO. Angle DPO equals to 2 pi minus 2 theta So the area of sector DPO will be equal to the angle between the legs, that is pi minus 2 theta over 2 pi times the area of the triangle, that is pi r squared, and r equals to 5. Here it is 5, so it is pi times 5 squared. Pi times 5 squared is 25. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. So in conclusion, the area of sector DPO, we'll open the brackets here, it is equal to (25) pi over 2 minus 25 theta 2 over 2. 2 over 2 is 1, so it will get cancelled. So here in conclusion, the area of sector DPO equals to 25 over 2 is 12.5, and this expression in total equals to 12.5 pi minus 25 times theta. So in conclusion, the area of sector DPO, this sector, equals to 12.5 pi minus 25, and we have already found out that theta equals to tangent minus 1 of 0.5. So this is the area of sector DPO, and we have to subtract from the area of sector DPO the area of triangle DPO. So the area of triangle DPO equals to the multiplication of the two sides together, dp times PO, that is 5 times 5, times sinus the angle between the two sides, that is pi minus 2 theta over 2. So here 5 times 5 is 25, and 25 over 2 is 12.5, and sinus pi minus 2 theta equals to sinus 2 theta, but we have already found out that sinus 2 theta equals to 4/5, so we substitute sinus 2 theta by 4/5. Here it is 25 over 2, and we'll get that the area of triangle DPO equals to 25 over 2, and sinus theta equals to 4/5, so we'll substitute sinus theta by 4/5, and we'll get that it is equal to, in total, to 25 times 4 is 100. In the denominator we have 10 times 5, 2 times 5 is 10, so 100 over 10 is 10. So in conclusion, we found out that the area of sector, this sector, the lower sector of the big lens, equals to 12.5 pi minus 25 times minus 1 of 0.5 minus 10. Okay, this is the area of the lower circular segment of the big lens. Okay. Now we actually have to add the upper circular segment to the lower circular segment. In this way we'll get the area of the big lens, and we'll subtract the area of the blue lens from the area of the big lens, and in this way we'll get the orange shape. So in conclusion, we will get that the area of the big lens is equal to the area of the upper circular segment plus the area of the lower circular segment of the big lens. Repeat again, that the area of the big lens equals to the area of the upper circular segment plus the area of the lower circular segment. We have already found out that the area of the lower circular segment equals to 12.5 pi minus 25 tangents minus 1 of 0.5 minus 10. This is the area of the lower circular segment plus the area of the upper circular segment, and we have already found out that the area of the upper circular segment equals to 100 times tangents minus 1 of 0.5 minus 40. So here we added the two areas together, and this is the area of the big lens. The area of the big lens equals to here 100 times minus 1 of 0.5 minus 25 times tangents minus 1 of 0.5 equals to 75 times tangents minus 1 of 0.5, and we have here plus 12.5 pi minus 10. Okay, so this is the area of the big lens, and we'll subtract the area of the blue shape from the area of this big lens. So the area of the blue lens, we have already found out that the area of the blue lens equals to 12.5 pi minus 25. So in conclusion, the area of the orange shape this is actually the shape of DPQ. This is the orange shape. This orange shape DPQ equals to the area of the big lens minus the area of the blue lens. Okay, that is to say it is equal to the area of the big lens. We have already found out that the area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 10. We have so this is the area of the big lens. We have to subtract from the area of this big lens the area of the blue lens, and the area of the blue lens equals to 12.5 pi minus 25. Okay, so we'll open the brackets here and we'll get that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 10. We'll open the brackets here. It will be equal to minus 12.5 pi, minus and minus is plus, so it is plus 25. So here we have 12.5 pi minus 12.5 pi is 0, so those expressions will get cancelled. And here we have here it is actually we have here it is should be minus 50 plus 25 is minus 25. So the area of the orange shape equals to 75 times tangents minus 1 of 0.5 and minus 50 plus 25 is minus 25. And we know that tangents of minus 1 of 0.5 equals to 0.46. So we have to multiply 0.46 by 75 and it is equal to 34.77 minus 25 equals to 9.77 square units. So in conclusion, I found out that the area of the orange shape, the area of this orange shape equals to 9.77 square units. Okay, I finished with the second method. In the next step I will summarize the lecture. We'll start with the first method, of course. So in the drawing we have a square ABCD. One side of square ABCD equals to 10 units. Inside this square we have two semicircles that intersect with each other. Semicircle DPC and the other semicircle is DPA. They intersect with each other, and by the intersection of each other they create a common area that is this common area. This is the blue lens, and they also have the quarter circle ABDQ that intersects with this semicircle, and they create the big lens, this big lens. The big lens is the common area of the two of the quarter circle with this semicircle. And our mission is to find out the orange area, that is the shape DQP. Okay, so the area of the shape DPQ, this orange shape, equals to the area of the blue lens minus the area of the big lens. This is the area of the big lens minus the area of the blue lens. Again, the area of the big lens minus the area of the blue lens give us the area of the orange shape, that is DQP. Okay, so we'll find out the area of the big lens, and then we'll subtract from the area of the big lens the area of the blue shape. This way we get the area that is requested, that is the area of the orange shape DQP. Okay? But first of all, I will explain to you what is a segment, what is the area of a segment, or the area of a sector. Okay, the area of a sector, the area of the green sector equals to the area of this circle that is pi r square, the radius is r, times theta over 2 pi. Theta over 2 pi is the ratio between angle theta to the ratio of all the circle, that is to say 2 pi is 300 degrees. Okay, in terms of degrees, 2 pi is 360 degrees. So when we divide the area of, when we divide theta by 2 pi, we get the percentage of the amount of the percentage of the circle that this sector occupies. And then we will multiply this percentage by the area of this circle. This way we get exactly the area of sector of this orange green sector. So theta over 2 pi times pi r square is the area of this sector, the area of the green sector. Then I presented to you what is the area of the green segment, segment AB, the circular segment AB, the area of circular segment AB equals to the area of sector AOB minus the area of triangle AOB. So if you subtract the area of triangle AOB from the area of sector OB, we get exactly the area of circular segment AB. Again, the area of circular segment AB, the green shape, equals to the area of sector AOB minus the area of triangle AOB. Okay? Then we actually took two semicircles that intersect with each other at 90 degrees, and they create here common area, and the common area is defined as a length. Okay, so we'll find out the area of this length, that could be any length, and then we'll use the general formula in order to find out the area of the big lens and the area of the blue lens. Okay, so we create general formula for the area of a lens. This lens could be any lens. Okay, so here we define the radius of this semicircle as A, and then we define the radius of this semicircle as B. Here we join points O and N. So here point O is the center of the semicircle, point N is a point on the semicircle itself. That is to say, line segment ON is the radius of this semicircle that is equal to A units, and the radius ON, it is drawn to the point of tendency. That is to say, it is drawn to point N, that is the point of tendency of tangent MN with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent MN will be perpendicular to the radius NO. So if MN is perpendicular to NO, it means that this angle equals to 90 degrees. Likewise, we have here the radius OL that is drawn to the point of tendency. That is to say, it is drawn to point L, that is the point of tendency of tangent ML with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent ML will be perpendicular to the radius LO. So if ML is perpendicular to LO, it means that this angle equals 90 degrees. Okay, then we join points O and L together by straight line, and join points N and L together by straight line. By joining points L and N by straight line, we created here two circular segments, the green circular segment and the orange circular segment. And the area, the sum of the areas of those two circular segments will give us the area of this lens. So, by finding out the areas of those two circular segments, the green and the orange, we'll find out the area of this lens that could be any lens. Okay, so what is the area of the green circular segment LN? The area of the green circular segment LN equals to the area of sector LON, the area of sector LON, this is sector LON, minus the area of triangle LON. Okay. Here, if we define angle LOM as theta, then this angle MON will be also equal to theta. Why? Because those two right triangles can go into each other. They can go into each other. Why they can go into each other? Why? Because those two sides are both equal to A, therefore they are equal to each other. Those two sides are both equal to B, therefore they are equal to each other, and we have a common side OM. Therefore those two triangles can go end according to side rule. Therefore those two angles be equal to each other. So if this angle equals to theta, then this angle must be also equal to theta. So the angle between the legs of sector LON is theta plus theta, 2 theta. And here also the angle between side LO and side ON, triangle LON, equals to 2 theta. And what is the area of sector LON? The area of any sector equals to the angle between its legs, that is 2 theta, over actually 360 degrees, that is in terms of radians is 2 pi, times the area of the circle, that is pi r squared. In this case r equals to a, so it is pi a squared. Okay, so here we have pi in the denominator, so pi will get cancelled. We have 2 in the denominator, 2 in the denominator, so 2 also will get cancelled. In conclusion, the area of sector LON equals to theta times a squared minus the area of triangle LON. We will not have to calculate the area of any triangle in the first method. Why? Because the sum of the areas of those two right triangles will be equal to A times B, and we will put this sum, we subtract from the sum of the areas of the two sectors, the area of the two triangles, that will be equal to A times B, and in this way we don't have to calculate the area of any triangle in this method. Okay, so I found out that the area of sector LON equals to theta times a squared minus the area of triangle LON that we will not calculate at all. Then the area of the lower circular segment, orange circular segment, will be equal to the area of sector NML, the area of sector NML, minus the area of triangle NML. Okay, the area of the orange circular segment equals to the area of sector NLM minus the area of triangle NLM. So here, in order to find out the area of sector NLM, we have to find out the angle between the legs of sector NLM. Okay? So in the right triangle OLM, this angle equals to theta, this angle equals to 90 degrees or pi over 2. Therefore, this angle must be equal to pi over 2 minus theta. In order to complete the sum of the angles in this right triangle 280 degrees, this angle must be equal to pi over 2 minus theta. Exactly for the same reason, this angle must be also equal to pi over 2 minus theta. We will add the two angles together, so pi over 2 minus theta plus pi over 2 minus theta equals to pi over 2 plus pi over 2, that is pi, and minus theta plus minus theta is minus 2 theta. So in conclusion, found out that the area of that angle LMN, this angle equals to pi minus 2 theta. Okay, now we can calculate the area of sector LMN, that it will be equal to the area of the angle between the legs of sector LMN, that is pi minus 2 theta, over 2 pi, that is 360 degrees, times the area of the circle, that is pi b squared, because r equals to b. So here we have pi in the numerator and pi in the denominator, so pi will get cancelled. And then we open the brackets here. We got pi b squared over 2, and then it is 2 pi times b squared over 2. here we have 2 over 2 is 1. So in conclusion, the area of sector LMN equals to pi b squared minus theta, pi b squared over 2 minus theta b squared. Then we join the two triangles together. So we created here quadrilateral LONM. Then we join points O and M together by a straight line. In this way, we created here two right triangles. Okay, what is the area of the green right triangle O and M? It is equal to the base of the triangle, that is B times the height of the base, that is A, over 2. So the area of the orange blue right triangle, the area of the green right triangle LOM equals to B times A over 2, while the area of the orange right triangle OMN equals also to the base, that is A, times the height to the base, that is B, over 2. So both areas are equals to A times B over 2. Then we added the two areas together, and we got that the total area equals to A plus B over A times B over 2 plus A times B over 2 is 2 times AB over 2. 2 over 2 is 1, so in conclusion found out that the sum of the areas of the two triangles equals to A times B. Okay? So we have to subtract A times B from the general formula for the area of the length. Okay? As I already mentioned, the area of this length equals to the area of the sum of the areas of the two sectors LON plus LMN minus the area of the two triangles, but the area of the two triangles is A times B. So we have to subtract from the area for the sum of the areas of the two sectors the area of the two triangles, that is AB. So we subtract from the sum of the areas of the two sectors A times B, because this is the area of the two triangles. Okay? So in conclusion, the area of the length equals to the sum of the areas of the two sectors, that is actually theta times A squared is the first sector, O, plus pi b squared over 2 minus theta b squared is the area of the second sector. So this expression equals to the area, the sum of the areas of the two sectors minus the area of the two triangles, but the area of the two triangles is AB. So we subtract AB, and in this way we get the area of the length that could be any length. That is to say, we can use this formula in order to find out the area of the big length, and also in order to find out the area of the blue length. Okay? So here we took theta as a common factor from those two expressions. So from this expression, what is left is, after we took theta as a common factor, is A squared, and from this expression, what is left after we took theta as a common factor is minus B squared. So in conclusion, the formula for the area of a length equals to theta times A squared minus B squared plus pi b squared over 2 minus AB. Then we focused on the right triangle LOM. In the right triangle LOM, we know that tangent theta equals to LM over LO, that is to say it is B over A. So tangent theta equals to B over A, but we don't want tangent theta, but we want theta itself. So in order to find out, because inside this formula we have theta, only not tangent theta. So in order to find out the value of theta itself, we will operate the opposite function of tangents on the result. In this way we get the value of theta itself. So we operated the opposite function of theta, that is tangents minus 1, on the result, that is b over a. In this way we got theta. So theta equals to tangents minus 1 of b over a. That is to say, we can substitute theta by tangents minus 1 of b over a. We did it here. And we found out that the area of the length, the general formula for the area of a length is a squared minus b squared, that is the square of the radii of the two shapes. And theta is tangents minus 1 b over a. So we substitute theta by tangents minus 1 times b over a, plus pi b squared over 2 minus ab. So here we have a special formula to find out, in order to find out the area of any length. So we will use this formula in order to find out the area of, in order to find out the area of this big lens, and then we use the same formula in order to find out the area of the blue lens. Okay? So the area of the big lens, here, this is the big lens. How the big lens was created? The big lens is the result of the intersection of the quarter circle with this semicircle. So A will be equal to the radius of the quarter circle, that is 10 units, and B will be equal to the radius of this semicircle, that is 5 units. Why the radius of the semicircle is 5 units? Because of the fact that the diameter is 10, therefore the radius must be equal to half of it. That is to say, the radius of this semicircle is 10 over 2, that is 5 units. So A equals to 10, B equals to 5. We put the data inside this formula. That is the formula, the general formula for the area of any length, and especially it could be good for to finding out the area of the big length. Here A equals to 10, B equals to 5. So A square is 10 square minus B square is 5 square times tangents minus 1. B is 10, A is 5, so 10 over 5 is 1/2, that is 0.5, plus pi B square. B is 5, so B square is 5 square, so it is pi 5 square, that is 25 over 2, minus A is 10, and B is 5, so it is minus 10 times 5. So the area of the big length equals to 10 square is 100, minus 5 square is 25. So 100 minus 25 is 75. So this expression in total equals to 75 times tangents minus 1 of 0.5, plus 25 over 2 is 12.5. So this expression in total equals to 12.5 pi, minus 10 times 5 is minus 50. So in conclusion, we found out that the area of the big length equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. Okay? So we found out the area of the big lens. In the next step we'll find out the area of the blue lens by using the same general formula for the area of any lens. So the area of the blue lens, it is equal to A square minus B square, but here how the blue lens was created. The blue lens is the result of the intersection of the two semicircles with each other. But we know that the radius of each semicircle equals to 5. So here A equals to B equals to 5 units, because they have the same on the eye of 5 units. So A equals to 5 units, B equals to 5 units. Therefore A square minus B square is 5 square minus 5 square times tangent minus 1 of B over A. B is 5, A is 5, so 5 over 5 is 1. Okay, but this expression will be equal to any way to 0, so we don't care what is here, because 5 square minus 5 square is 0. Plus pi B square. B is 5, so B square is 5 square, that is 25. So in conclusion, this expression equals to 25 pi over 2 minus A times B. A is 5, B is 5, so 5 times 5 is 25, so it is minus 25. So this expression 5 square minus 5 square is 0, and we left only with 25 over 2 is 12.5, so this expression in total equals to 12.5 pi minus 25. So in conclusion, we found out that the area of the blue lens equals to 12.5 pi minus 25, and we have already found out that the area of the big lens equals to 75 times tangent minus 1 of 0.5 plus 12.5 pi minus 50. So we subtract the area of the blue lens from the area of the big lens. In this way we get the area of the orange shape. So the area of the big lens equals to 75 times tangent minus 1 of 0.5 plus 12.5 pi minus 50. And the area of the blue lens equals to 12.5 pi minus 25. So we subtract one from each other. In this way we get the area of the orange shape, that is the area of DPQ. So here we have 75 times tangent minus 1 of 0.5. We open the brackets here. So this is minus 12.5 pi, minus is plus, so plus 25. Plus 25. So here we have 12.5 pi minus 12.5 pi is 0. And we have also 25 minus 50 is minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangent minus 1 of 0.5 minus 25. And tangent minus 1 of 0.5 is 0.46. So we multiplied 0.46 by 75, and we got that it is equal to 34.77, and we subtracted from it 25, and in conclusion found out that the area of the orange shape DPQ equals to 9.77 square units. In this way we finished with the first method. Then I presented to you how to find out the area of the orange shape DPQ according to the second method. In the second method, we didn't use general formula for the area of any lens, but we calculated directly the area of the big lens, and then we calculated the area of the blue lens, and we subtracted the area of the blue lens from the area of the big lens, and in this way we found out the area of the orange shape DPQ. So first of all, we found out the area of the blue shape. So here we drew the blue shape here. The blue shape is the result of the intersection of the two semicircles with each other. The common area creates the blue shape. So this is the blue shape, and we have to find out the area of this blue shape. So the area of the blue shape, this blue shape, will be equal to the area of the green circular segment times 2, because these two circular segments are identical, so they have the same areas. So if we multiply the area of this circular segment by 2, we'll get the area of this all blue lens. So what is the area of this circular segment Ln? It will be equal here to the area of sector LON, the area of this sector, minus the area of triangle LON. Repeat again, the area of circular segment LON will be equal to the area of sector LON minus the area of triangle LON. So the area of circular segment, the area of sector LON, actually sector LON is a quarter circle, and the area of any quarter circle equals to the area of the circle over 4. So the area of this circle with radius r that is equal to 5 will be equal to pi times 5 square, and then we have to divide it by 4 in order to find out the area of this quarter circle. So the area of this quarter circle in conclusion equals to pi times 5 square over 4 minus the area of this right triangle LON. The area of the right triangle equals to the multiplication of the two sides together over 2. That is to say, it is 5 times 5 over 2. Okay? Then we multiplied the area of this circular segment by 2, and this way we found out the area of the blue shape. Okay? So the multiplication of the area of the circular segment by 2 gave us the area of this blue shape. Here 2 times 25 pi over 4 equals to 25 pi over 2, and 2 times 25 over 2 equals to 25. So in conclusion, the area of the blue lens equals to 25 pi over 2 minus 25. 25 over 2 is 12.5. So in conclusion, the area of the blue lens equals to 12.5 pi minus 25 square units. Then we found out the area. So here 12.5 pi minus 25 is the area of this blue lens. In the next step, we'll find out the area of the big lens, and we'll subtract the area of the blue lens from the area of the big lens. In this way, we'll find out the area of the orange shape, DPQ. So here, actually, the big lens was created by the intersection of the quarter circle with this semicircle. In this way, created the common area of the big lens. So we'll find out the area of the big lens in two steps. First of all, we'll find out the area of circular segment DO, that is the upper side of the big lens, and then we'll find out the area of the lower circular segment OP, and then we will add the two areas together, and this way we will get the area of the big lens. Okay? So what is the area of this circular segment DO? The area of this circular segment DO or LN it is equal to, so here we already found out the area of the circular segment DO equals to the area of sector DAO minus the area of triangle DAO. Okay? So the area of this circular segment DO equals to the area of sector DOA. This is sector DOA minus the triangle DOA. Okay? In order to find out the area of sector DOA, we have to find out the area between its legs and the angle between its legs. So here, those two triangles can go into each other according to side rule. Those two sides are equal to 10, therefore they are equal to each other. Those two sides are both equal to 5, therefore they are equal to each other. And this is a common side AP that is equal to itself. So if this angle is theta, this angle also must be equal to theta because they are equal to each other. So the area between the legs of sector DOA is 2 theta. And this is also the area between sides DA and AD in triangle AOD. So here the area of sector DAO equals to the angle between his legs is 2 theta over 2 pi times the area of the circle that is pi r square, and r equals to 10, so it is pi 10 square. This is the area of sector AOB or the AOD. Here we have theta in the numerator and theta in the denominator, so theta will get cancelled. We have 2 in the numerator, 2 in the denominator, so 2 also will get cancelled. So, in conclusion, the area of the sector DAO equals to theta times 10 squared, that is 100. So it is 100 times theta minus the area of triangle DAO. Here the angle between DA and AD is 2 theta, AD is 10, AO is also 10. They are the radii of the quarter circle. So it is 10 times 10 times sinus 2 theta over 2. This is the area of triangle DAO. Here 10 times 10 is 100 and 100 over 2 is 50. So in conclusion, we found out that the area of triangle DAO equals to 50 times sinus 2 theta. And in conclusion, the area of the upper segment of the big lens equals to 100 times theta minus 50 times sinus 2 theta. Okay? Then we draw triangle ADP here. and we know that sinus theta equals to 2 times sinus theta cosine theta. Then we implemented the Pythagoras theorem on this right triangle, triangle ADP. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, dp squared plus ap squared equals ad squared plus dp squared equals to ap squared. That is to say, 10 squared plus 5 squared equals to ap squared. 10 squared is 100, 5 squared is 25, so 100 plus 25 is 125. So in conclusion, we found out that ap squared equals to 125, so ap equals to the square root of 125, and 125 is 25 times 5. We took out of this equation and found out that AP, the hypotenuse AP in this right triangle, triangle ADP equals to the square root of 25 is 5, and inside the root we left only with 5. So the hypotenuse AP equals to 5 times square root of 5. Okay? Then we also, so we know that sinus 2 theta equals to 2 times sinus theta cosine theta. That is to say, sinus 2 theta equals to 2 times sinus theta. But what is the value of sinus theta according to this drawing? Sinus theta equals to dp over ap. dp is 5 and ap is 5 over square root of 5. So in conclusion, sinus theta equals to 5 over 5 times square root of 5 times cosine theta. And what is the value of cosine theta according to this drawing? Cosine theta according to this drawing equals to AD over AP. AD over AP, but AD equals to 10 and AP equals to 5 over square root of 5. So in conclusion, cosine theta equals to 10 over 5 square root of 5. Okay? So in conclusion, sinus 2 theta equals to this expression. Here we have 5 in the numerator, 5 in the denominator, so 5 will get cancelled. So in the numerator we have in conclusion 2 times 10, and the denominator we have square root of 5 times square root of 5 is 5, so it is 5 times 5. So here 10 over 5 is 2, so in the numerator we left only with 2 times 2, that is 4, and in the denominator we left only with 5. So in conclusion, 2 times 2 is 4 over 5. So in conclusion, we found out that sinus theta equals to 4/5. Okay? And then we found out tangent theta, or in this triangle, tangent theta equals to dp over AD. dp over AD, dp equals to 5 and AD equals to 10. So, and 5 over 10 is 1/2 or 0.5. So if tangent theta equals to 0.5, we'll operate the opposite function of tangents on the result, and it will give us theta itself. So the opposite function of tangents is tangents minus 1, operated on the result that is 0.5, and we found out the value of theta. So tangents minus 1 of 0.5 equals to theta. Okay, so in conclusion, we found out the value of sinus theta equals to the value of sinus 2 theta equals to 4/5, and theta itself equals to tangents minus 1, that is the opposite function of tangents, of 0.5. We have already found out that the area of the upper circular segment equals to 100 times theta minus 50 times sinus 2 theta. Here we will substitute theta by tangents minus theta of 0.5, and we'll substitute sinus 2 theta by 4/5. So we did it, and we got that it is 100 times theta is tangents minus 1 of 0.5, and there it is 50 times sinus theta, but sinus theta equals to 4/5, so we substitute sinus theta, substitute sinus 2 theta by 4/5, and we got that the area of the upper circular segment equals to 100 times tangents minus 1 of 0.5, and here 50 over 4 is 200, and 200 over 5 is 40. So in conclusion, the area of this upper circular segment of the big lens equals to 100 times tangent minus theta of 0.5 minus 40. Okay? So we finished with the upper side of the big lens. Now we'll find out the area of the lower side of the circular segment, DO. Okay, what is the area of this circular segment? Here, the area of this circular segment, it will be equal to the area of sector DPO. This is sector DPO minus the area of triangle DPO. Repeat again, the area of the lower circular segment equals to the area of sector DPO minus the area of triangle DPO. And we already found out that the area between the legs of the sector is pi minus 2 theta. Therefore, the area of the sector itself will be equal to pi minus 2 theta over 2 pi times the area of the circle, that is pi r squared, and r equals to 5. Therefore, it is pi times 5 squared, that is 25, so it is pi, 25 pi. Here we have theta in the numerator and theta in the denominator, so theta, pi in the numerator and pi in the denominator, so pi will get cancelled. Then we open the brackets here, it is 25 pi over 2 minus 2 theta minus 2 times 25 times theta over 2. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. So in conclusion here, the area of the lower circular segment equals to 25 over 2 is 12.5. So it is 12.5 minus 25 times theta. Here theta equals to tangent minus 1 of 0.5. So we substitute theta by tangent minus 1 of 0.5. So in conclusion, we found out that the area of the lower circular segment of the big lens equals to 12.5 pi minus 25 tangent minus 1 of 0.5 minus 10. Now the area of the big lens equals to the area of the upper circular segment plus the area of the lower circular segment. Okay? So the area of the upper circular segment equals to 100 times tangent minus 1 of 0.5 minus 40, while the area of the lower circular segment equals to 12.5 pi minus 25 minus 25 times tangent minus 1 of 0.5 minus 10. So the area of the big lens equals to here 100 times tangent minus 1 of 0.5 minus 25 times tangent 1 of 0.5 is 75 tangent minus 1 of 0.5 minus 40 plus minus 10 is minus 50. And here we have also 12.5 pi. Okay, in conclusion, the area of the big lens equals to 75 times tangent of minus 1 of 0.5 plus 12.5 pi minus 50. This is the area of the big lens, but the area of the blue lens equals to 12.5 pi minus 25. So we subtract the area of the blue lens from the area of the big lens, and we get the area of the orange shape. So the area, in conclusion, the area of the orange shape equals to the area of the big lens minus the area of the small, the area of the big lens minus the area of the blue lens. The area of the big lens equals to 75 times tangents minus 1 of 0.5 plus 12.5 pi minus minus 50. It is minus 50, and the area, so here, and the area of the blue lens equals to 12.5 pi minus 25. So we subtracted the area of the blue lens from the area of the big lens. So here we open the brackets, and here we get 75 times tangents minus 1 of 0.5 plus 12.5 pi minus 50. We open the brackets here, so here it is minus 12.5 pi, minus is plus, so it is plus 25. So here we have, in conclusion, 75 times tangents minus 1 of 0.5, 12.5 pi minus 12.5 pi is 0, and minus 50 plus 25 is minus 25. So in conclusion, we found out that the area of the orange shape equals to 75 times tangents minus 1 of 0.5 minus 25. And tangents minus 1 of 0.5 is 0.46. So we multiplied 0.46 by 75 and found out that it is equal to 34.77. And the area of the orange shape equals to 34.77 minus 25, that is 9.77. So in conclusion, we found out that the area of the blue shape, the area of this blue shape equals to 9.77 square units. Okay, in both methods we found out that the area of this orange shape, dpq, equals to 9.77 square units. Okay, thank you very much.